Okay, good morning. My name is Mike here. I'm the founder and CEO of the Product Realization Group, and we have a good audience here. Hopefully everybody had okay time parking. We also have a good number of people on the webinar, and we're going to be tracking questions and look forward to questions both from people inside as well as from on the webinar. So just a quick show of hands. Who's heard of the Product Realization Group, or everybody familiar? Okay. Obviously these guys up here. So we're a technical consortium located in Silicon Valley. We've got about 20 companies part of the group, ranging from design all the way through manufacturing and shipping and logistics, and really focused on getting products to market. That's the core focus of the group. Okay, you can advance, Mike. Okay, and I'm not going to go through too much about the group. This is just a little bit of a sample of some of the partners that are in the group. So you can see, ranging from early on, mechanical design. Mark does mechanical design. Walt does electrical design. Barbara does plastic molding. Business systems. Mike does reliability, packaging, consulting, software, so kind of a variety of different things, and really servicing a variety of industries and clients. Ranging primary focus is on medical, networking, telecom, clean tech, and consumer. Those are the core focus. But we do defense and other products as well. And if you look at the group as a whole, there's a whole bunch of companies that we're actively working with. Okay, so a little bit about upcoming events. So every year we have an annual symposium and barbecue where we try and focus on kind of a core emerging topic or two. So that's coming up on September 17th. I think there's a card on your desk you can see, or if for those in the audience, you can look on the website and find out more details about that. We also started a certificate program about 2 or 3 years ago, and that's starting up again on September 25th, and that goes through end-to-end from design all the way through supply chain in 5 different modules. Okay, and if you want to learn more about any of the events, feel free to go to the website. They're all live on there. And then we've been doing the seminar series for I think about 5 years now, so it's been a long time. And really the idea was there wasn't a lot of dedicated forums about the product realization process or about product development process. So the idea was how do we get people together, either in person or online, and go through that process. So that's the goal. We're trying to always highlight what are the current best practices, what are the latest tools out there, and then for those here, also to provide a local networking forum. Okay, so I always like to start with a little bit of, what's the latest news out there. Got a little mash, but that's a kind of a fancy one of these hot Dodge cars. Turns out May 7th there was a recall. Fuse can affect the brakes. Obviously, affecting brakes on a car probably isn't the best idea. So they've recalled 119,000 in the U.S., 8,000 in Canada. And the whole framing of this is about managing risk, right? I mean, if you get to a point in a product where you're driving a car and the brake fails and somebody dies, that's not where you want to be. Okay, so this question is really directed for those in person, but just a quick show of hands. How many people are directly in product development? Okay, how many in quality regulatory? Okay, operations manufacturing? Okay, more than one? Okay, management? Okay. All right, so I'm going to give just a quick overview. This is not a detailed. This isn't really a lecture about product development, but it's kind of to frame the topic. So I'll talk a little bit about, what's involved in the product development process or the design process, and I'm going to take a standard medical approach, which is probably a little more rigorous than some, but it's has everybody seen this? I mean, it's pretty common. And the idea is you define user needs, you have design inputs. You go through the development process, the design process, you have design outputs, you verify that those meet the inputs, and then you have a device. And this could be a medical device, it could be other device as well. And then you validate that device actually meets the user needs. Okay, and then you ship. And if this process goes well, at the end of it, you get a product that people want. Okay, so some of the key aspects: scheduling, key tips: create, revise, review. Scheduling is critical. Get buy-in from all the team members. Key aspects of a schedule are creating a specification. What are all the items, and then reviewing everything on a regular basis to make sure you're on track. Okay, here's an example Gantt chart. This is a little bit of an eye chart, so I'm not going to go through a lot of detail, but you get an idea that there's a bunch of different things that need to be done in key different areas, and then they all relate. And at the end of it, if everything gets done on time the way it's supposed to, you end up with what you want at the end. Okay, the other thing is budgeting. A lot of companies don't always take into account NRE charges. Project management, design, prototyping, testing. They want to get to the product before all these other things. But whenever you're just developing a product, you've got to account for all these things in a budget as well as your schedule. Okay, and then here's an example of tracking, and you can see that the purple is budgeted. What you're supposed to spend in the various phases. The red is what was used, and then the yellow is allocated. So, you can see in some cases that the budget was exceeded. In other cases, the project came in under budget. But using these kind of tools allows you to keep projects on track and manage both the time and the cost. Okay, design outputs. What are some typical design outputs? And these would correspond to the design inputs, just like we saw in the chart earlier. And primarily, this is going to be documentation. So when you're done with the design process, you're going to have a set of documentation that's sufficient to build a product. So what does this look like? Schematic, layout, bills of materials, mechanical drawings, software, manufacturing procedures, notes, and test results. Just this isn't everything, but it gives you again a flavor of some of the things that are involved in that. Typical electrical outputs would be schematics, PCB layouts, and bills of materials. Okay, and then mechanical drawings, bills of materials, manufacturing procedures, and test procedures. Okay, so with that very brief overview, I'm going to let the experts here share their knowledge. We're fortunate to have 4 very senior level people covering a variety of different areas. And I'll start by introducing Barbara Roberts. In fact, I'll let her introduce herself. So Barbara, you want to?
Yes, Barbara Roberts, President and CEO of Wright Engineered Plastics. We are a local injection molder and custom fab assembly operation in Santa Rosa. We do precision injection molding. We've been around quite a long time. We also have added a clean environment room. For those of you in medical, it's a CER, not a clean room, but it helps to produce medical products, including surgical devices. Our customers have had reliability issues with joining and fastening, so one of our expertises that we've developed is insert and overmolding, and we have the ISO certification for medical.
Thank you, Barbara. Mark, yeah, go ahead, Mark.
Mark Brinkerhoff, one of the owners of Fusion Design. We're a product development company. We do industrial design and mechanical engineering and have done so since 1990, so 22 wonderful years. Anyway, we do both products and equipment. We have our own shop. We're right down here in Campbell, and I can't keep track of how many products we've done, but it's approaching 1,000 so far, so it's a lot of products.
Great. Thank you, Mark.
It's amazing how we actually sat in order. What are the odds? Oh, you did? Oh. Oh, so this was actually a plan. Okay. So, I'm founder and managing partner of a consulting firm called Ops a la carte. We focus on reliability consulting, testing, training, provide full solutions for clients or individual a la carte solutions our real emphasis with clients is we just want to make sure that your product doesn't fail in the field, and that's so people hire us to accomplish that goal. We have our own test lab here in the Bay Area where we do all of our own product reliability testing, but a lot of what we do happens well before the testing to make it sure it's designed in and designed reliably. I have a book that I put out last year, talks about our methodologies, and we're promoting a new method now called an ounce of prevention strategy, OPS, which really you apply to that, and you're going to essentially build it all in up front so that you don't have any problems on the back end.
I'm Walt Maclay. The company is Voler Systems. We do electronics and software. A lot of what we do is medical devices, but that's not the only thing. We specialize in medical devices, sensor interfaces, motion control, and wireless. And we've been doing this for 13 years. I don't know. We don't have 1,000 projects yet, but lots of them, several hundred.
Thank you. And as I mentioned, my name is Mike here, and I've been doing product development for over 20 years, actively involved either on the OEM side developing products or on the contract manufacturing side manufacturing high-tech electronic products. And I've spent the last 5 years kind of building this technical consortium called the Product Realization Group. Okay, so with that in mind, I'm going to get into the question part of it. So we make decisions every day. We make trade-offs. Some are related to time, appearance, performance, or cost. These are all going to ingest risk into a product development cycle. And yet we don't want undesirable outcomes. Just a question, how many people have been directly impacted by a product failure or a product recall in the audience? And how, what was the nature of? Oh, the car. And some of the others?
I've had a number of consumer electronics that I've had this impact for.
Just failure? Yeah. And just failure. Consumer product or? Yeah. Yeah, and those are usually fairly minor, but if you get to something like a hip replacement and it fails, it can be very serious. Or an automobile that, that catches fire. Especially if you're in it. So with that in mind, we're going to talk about what are some of the techniques that you can use to mitigate risks. And I don't know if you can see this graphic here, but you don't want to be in the red convertible behind. Okay, so and this is just to get a little idea of build, plan, revise, and I'm going to have Barbara start by giving her take on tips for managing risk.
Because we're involved in the assembly process, whoa, I'm sorry. I didn't realize I was going to do that. We see that many of the risks result from too many assembly steps or assembly steps that haven't been planned for well. So that's why I recommend eliminating as many as you can, if you can, and that even having your suppliers provide you with sub-assembled components is oftentimes less risky than assembling them yourself if you have too many steps. And then along the way, there'll be, if you test each step, then that, because sometimes problems can be masked in the final assembly and you can't see inside that there is a problem. So we oftentimes can assemble and then do like an actual overwrap on an assembly so it can't come apart. Getting feedback from your suppliers is really important. I'm reminded of something that I said a long time ago to one of my managers who says, why does Mike make more money than me? Why is he so much more valuable? This is another manager. And I said, because he tells me when I'm wrong. And I think that your most valuable suppliers are going to be the ones that tell you that this is maybe not the best way to do it. It might even mean less money for them, but if it isn't better, then it's the wrong thing to do. And you'll find that you're going to value those kinds of suppliers a lot more. So collaboration is very important. And then we also want to make sure that you fixture, we sometimes inherit fixtures from customers that have been designed by engineers. And the engineers are brilliant and then it's going to go to an assembler who is maybe not as full, doesn't understand as fully what its function is. And so they'll put in the part upside down. So you want to make sure that you design your fixtures for assembly by somebody who does not understand the full product's function. So one of the examples that I like to show is in terms of testing is also to talk about the possibility of tolerance stack up, and also to test your product design using those min-max tolerances. So the next slide is the picture of how I would represent this. For example, you could design this product and all those shoes would fit and they would actually work, and then you use a different shoe with a different tolerance and you suddenly are going to fall over in your bicycle. And besides, I actually don't think that's a very good design. It's not going to go into high volume manufacturing. So here's Mark.
Okay. Oh, no, that's fine. Okay, so my tips for managing design risk is the first one's find the best fabricator for that particular part or device, and I have a story to go with that. We did a parabolic antenna system for cellular backhaul. That may make sense to a lot of you because you're in the valley, but most others it may not. And it had a very tight tolerance, and it was a key part of a design for communicating cellular signals from A to B. Well, if we did it the old way, it would have been very, very expensive in tooling, a cast part and so on. Well, we wanted to do it with spun metal. If you've heard of metal spinning, it's a controlled forming process that can make a parabolic dish. Well, it turns out not everybody, they're not all equivalent. The manufacturers are not all equivalent in that space. So I called the manufacturer of the best equipment that I could find and asked who made their product shine. And they referred me to somebody who makes helicopter parts in the metal belt of our country. So I went out to Deacon's Metal Spinning and found someone who could hold tolerance within 0.02 over a parabolic dish that was 3 feet in diameter. And they made hundreds and hundreds of them successfully after that. So the point is, find the best in your space if you truly need it. And their price wasn't a problem either, so that was a good one. The next point I think is good for managing risk is, I call it plan for the worst and shoot for the best. I believe that product requirements should have a min-max tolerance. That doesn't mean dimensional tolerance, but functional tolerance. For example, what is your minimum product solution, whatever it is, and make sure you understand that really well, and what would be perfect if you had it. So you're probably going to end up somewhere in the middle of that, and so you will have to make compromises throughout your process to mitigate risk. And if you do that properly, you'll end up with a product that will sell in the marketplace if you've done your homework and be producible at the same time. So that's that one. The other one I call lead the target. If anybody's a skeet shooter, you got to lead the target. And technology is that way, especially in the Valley. There's so many technologies that are all moving in different directions and different speeds, and they converge. And you're seeing it right now. We live in a fantastic time for this, but there's new technologies that you and I may not have visibility on. So what I'm saying is understand the technologies that will converge with your product solution in the future. Understand when that will occur, and then if it's reliable enough, in your opinion, then develop a plan that merges you with that. You'll be the first in the space to provide that product with a good solution. So I'll pass to Mike.
On the same target theme here, we'll talk about, for reliability, probably one of the best things you can do is develop a reliability goal. What do I mean by that? Has anybody ever developed a goal or know what their goal is for their product? What's your goal for your product?
Well, I set different goals for different aspects of the product. But for instance, I'll go to my team and say, okay, the battery performance needs to be this long and this confined to the space, so we need to engineer the electronics to be disaffected at conserving the battery life.
Sure. Sure. Great.
You know, if a component that maybe has a fail time of X hours, and we say the average user is going to work this many hours per day on the component, how many years is going to last?
Perfect. Okay. So developing a reliability goal, talking about reliability versus usage. Okay. How about somebody else said there? Yes. Percentage failure per quarter. Great, great, great.
Is that like MTBF or some other parameter? Or
The
is it
failure
a-
rate, percent failure rate.
Okay.
Yeah, right. And that's a pretty common one. But there's other goals that you'd want to think of also. And you want to think of the longevity of your product, how long it's going to last before it goes into obsolescence, or before you're not going to service the product anymore. The warranty period of your product. Now we're getting to very long life kinds of products, solar, wind power products. These are oftentimes 20, 25-year products. So for those things like an MTBF or a failure rate may not be as good of a goal as I want this product to last 20 years before failure. So we have different ways that we express reliability goals depending on the environment. If it was say a mobile phone, maybe one of the best goals would be a dead-on arrival or out-of-box failure rate for the phone, because that's really very important to customers. I have a story behind that. I was talking with a fan supplier. You guys have all used blowing fans in your product. And we're actually talking with the CEO of the company. He was asking us to do some reliability analysis. And so we asked him what the goal for his product was. And he said, well, it's 50,000 hours MTBF. We said, all right, well, how did you arrive at that goal? He goes, well, that's because that's what all the other competitors in the industry are, so that's what we want to do. Well, as a matter of fact, an MTBF for a fan is absolutely the wrong goal, because it doesn't actually explain the key failure mechanism of a fan is it's going to wear out, and that's what we're most concerned about, or usually one of the most concerning things. So you have to make sure that you apply the right type of goal to the product and to the environment. The next thing, once you've developed a goal, you have to develop a plan in order to actually meet the goal. And I've seen very few companies do this or do this effectively, where they've actually put down not only what they're planning to do in their overall program, but how are they going to prove that they're going to meet their overall goal. Sometimes in the UK, they've now actually coined the term a reliability case. So rather than just saying, here's my goal to meet the product, you actually have to provide a case where you're saying, this is my evidence that what I'm going to do in this program is actually going to meet what I intend to meet. And with me, if I was a customer, I'd absolutely want to see that. In fact, in the military, they're very much going that way. It used to be, well, we're going to give you the requirements, and then we're going to cross our fingers and hope that we get what we want. But now a lot of it is changing. They're saying, now you, the supplier, are going to have to tell us how you're going to meet that goal. Until you can prove you are, we're not going to give you any money. And so it's refreshing to see that happening, because now you're going to see a lot of defense contractors having to work a lot smarter. And the next one, an obvious example of, let's look at what are some of the key failures of our product early on in the design. Oftentimes when I tell people that I'm in reliability, they say, oh, well, tell me what kind of testing you do. You don't want to get to the testing stage to find out something like this. I mean, that's going to require a complete redesign if in your testing you find some sort of a brake failure or in early prototypes. You want to find that out in the design phase. So you want to look at failure identification. Sometimes we call it FMEA, sometimes we call it risk analysis. It has a lot of different terms, but really it's looking at what are some of the key risks and key failures of the product as early as possible.
So one of the key things I look at in electronics is to select components that are available. And a key way is if it's in stock at a key supplier. If you can't find it when you're designing it, think about the guy trying to find it 5 years from now to use in your product. But you can go further than that. An example, we had a part where it was a RAM chip, and it was a good price. It was in stock in volume. And in fact, it was a very good price. And by the time we were through designing and we were ready to order for manufacturing, it was not available. It turned out it was used in a cell phone. So if we had known that it had been used in a cell phone, we would have been aware that it's going to have a short lifetime. So you've got to know even more than that it's in stock. And you can work with the distributors, and there are a number of ways to guarantee that something will be around. This is a real problem for things like medical devices, where it's probably 2 years before you even get it into the market. Another thing is to evaluate the risky technology first. It's human nature to do the easy things first. I'll get to that hard thing later on, and that's exactly the wrong thing to do. Anything that's hard, you want to do first. You can predict the easy things. You can't predict the hard ones. In some cases, you'll check something out and you'll cancel the project as a result because you find you can't do it. You better do that at the beginning of the project rather than in the middle. And don't try combining everything difficult. A short schedule, tight specs, and a small budget. I know you've never seen a project like this, right? It happens all the time. And what happens when you do that? Something usually gives. You've got tight specs, so you work longer on it. You're late, you're over budget. At least try and have a little leeway on one of those. Sometimes what you can do is you can take the tight spec and loosen it up for the first product. When you get that product in the market, then you can redesign and you can tighten the specs, improve the specs, change the design, and offer an upgrade. At least you've got something in the market and you're making money. And making a change is easier than doing the project in the first place. So the risk is lower to go to that tighter spec.
Okay, so the next question is about communicating risks. So what are a couple of techniques that you use for communicating risk at the design team level? And we'll start with Barbara and then go down the line here.
Well, we have a weekly meeting of our management team to work on any projects that are in development, which means that we basically always have a weekly meeting because there's always something in development. And then beyond that, we try to have as many meetings as possible with the engineers on the design team to try to communicate what's happening. And the reason that that's so important is because oftentimes there are what I would call undocumented specifications, and they are uncovered during a lot of this communication, where suddenly we realize that it's going to have an airtight seal, and wait a minute, it's not air, it's actually gas, and so the gas particles are smaller than oxygen, so we've designed an airtight seal, and suddenly we need more than that. And so that's a part of why it's so important to continue to communicate. And the other thing is components, mating components. Oftentimes they're in development at the same time, so you can't get your hands on those mating components. But if you can be talking to the suppliers, I'll be talking to the engineers and getting together, we can collaborate on and ultimately get a design that will fit together with all the components working. So that's why communication is so critical. In terms of transferring from development to high volume, that's oftentimes in my situation, I'm working with the OEM, R&D engineers, and then suddenly it's going to be made by Flextronics or somebody else, and I'm shipping to Shanghai, right? So I have a number of issues that correspond with that. Number one, the engineer says, oh, that's fine, it's okay that way. And I said, well, as soon as it goes to Flex, they're going to reject it because you got to get that into the specs. And so, again, it has to be really very well documented what's okay. And so I'll just transfer over to Mark now. Thank you.
One more slide.
Oh, I forgot about this one. I do want to talk about this. This is, again, an example of that. It's going from the product development stage to the manufacturing stage, and I love this picture because it's so true. You're the chef, and you're making this. You've got this recipe, and you're sitting there and you're making it. And I don't know if you cook it or if you know anything about cooking, but you make these creative decisions when you're cooking, and you don't necessarily write them down on your recipe. Okay. But you just know when you're supposed to take it off, when you're supposed to take the pan off the heat and how many times to stir it. You just do it. You just know it's supposed to look that way when it's done, and then you're going into high volume production, and it doesn't work. You can't make 14,000 cakes and have them all turn out the same way with that recipe. So you have to be much more exacting on your recipe when you transfer to high volume. Thanks.
So focus and brainstorm solutions weekly. I believe the human mind needs as much exercise as the human body, the rest of the body. And in fact, I believe groups need that kind of exercise on a regular basis. And so what I promote is to brainstorm often. And you learn how each other thinks, and synergies happen. In fact, I've taken it to the degree where every staff meeting we have at my company is one where we all draw pictures. Can't write anything. You have to draw a picture of what you're working on or a challenge that you're facing. Everybody else in the room has to guess what it is. So you can imagine at first it's pretty ugly. People are afraid to draw. Everybody thinks they can't draw, but they all can. And what it does is it exercises the group mind. So communicating risk through a group mind approach is very effective. Works well for us. The other one I like is I call it define, track, and posting the target. So if you know what your goals are and you make it very visible to the whole team, it aligns everyone marching to the same step. And often I've seen where entire development programs are exceedingly done well in certain areas and exceedingly lacking in others only because they didn't know what the other team or group was doing. So post regularly. The third one is I've seen a lot of mistakes made where people don't consult an expert in an area, and there's usually someone who's done what you're trying to do many, many times. And if you can find them and just ask them a few simple questions, you can knock months out of a problem schedule that might be in front of you. So I believe in having a really strong network, so I actually spend probably 25% of my time just building the network. So, Mike?
Mark, do you know where we could find any experts?
Goes without saying.
So one of the first things we do is there's so many different things that you're looking at during product development, whether it's reliability or design. So we like to use a dashboard approach. I'm sure everybody has their form of a dashboard. So what I mean by an organic dashboard is just something that works within your company that you've grown and it works for you. And it could be color-coded, however it is, but just make sure that it's easy for the people to use. Not a lot of words. I mean, red, yellow, green works great. But make sure you have the key things on there that you're tracking, because there's a lot of things. You could have 4 different things in life test. You could have something in design review, and you just need to know where everything is to find out, okay, today, am I at less risk than I was yesterday? How's the program going? So it's a very great way to communicate not only to the rest of your peers, but also to the management. And one of the key strategies, or the key things that I found over the years that it has gotten more complex, is reliability testing schedule, because products tend to last longer, and so the testing oftentimes takes longer. The physics hasn't gotten any different. If you're still on this planet, you can only accelerate tests at a certain amount. We're getting smarter about how to, but there's only a certain amount of acceleration you can do. But products are now lasting longer, so instead of having a product last 3 years, now it's like 5, 10, 20 years. So how long is a test going to take? And compounded by the fact that now schedules are getting compressed. So what we find is that we go into companies and they say, oh, we need to develop this accelerated test, and oh, by the way, the product is shipping in a month. Can you have the results for me in 2 weeks? This might be a 6-month gasket life test that we're doing, but I need the results in 2 weeks because we're shipping in high volume in a month. So you have to make sure that your testing schedule is well integrated with your design and your shipping schedule. Otherwise, you're going to find yourself finding problems maybe a little bit late in the game. Now, one of the things that we've done is we develop reliability testing schedules that are not a go, no-go, but actually you have various levels of confidence along the way. Say, all right, we're at 60% confidence. It's okay to start doing an early ship. Now we're at 80% confidence. Now it's okay to do a higher volume ship. Because by the time you get to the 95% confidence you want, your product might be 6 months late to the market.
So the number one thing I say about communicating risk is over-communicate. Humans have a tendency, many of us, to under-communicate, particularly engineers. I'm sure you've known an engineer who under-communicated. So to compensate, I tell everybody to over-communicate. And even myself, I find that there are times when I'm saying to everybody over-communicate and I fail to communicate enough. So I can't emphasize that enough. And when you'll communicate, you want to do it in writing, you want to do it verbally. Everybody has different ways of communicating, and you do it multiple ways and you're more likely to get the message across. And one good way of communicating is writing good specifications. and you want to write good specs at the beginning of a project, I sometimes have clients come to me and they give me a short paragraph and they figure that I should be able to quote the project and do it because they've given me a description. Well, the quality of what you get and the schedule and the results are going to depend very much on how well you specify it. And if you don't tell me very much, then we'll make decisions that are the best choices that we think, but may not be the best choices that you want. And it'll affect the reliability of the schedule and the cost. So be sure and do the specifications carefully. Now, there can be a limit. The tendency is not to do enough, but you can overdo it. If you're in a big company, that's probably good to overdo it. Big companies, the risk of failure of having a good spec is very high. In a little company, you can't afford to overdo it. And all I can say is it takes some experience to know exactly when you have enough. But if you have a doubt about whether you've got enough of a specification, do more. Another part of communicating is having all the stakeholders involved, everybody. The customer is represented by marketing. You've got engineering. You've got the manufacturing. You even have customer service. And finance has to pay for it, right? They got to allocate the money. If everybody isn't on board, what's going to happen later on? You know, we have a problem just getting all the engineers to agree on the specifications. But you've got to be sure that when you hand this thing over to manufacturing, that they say, yes, I'm in agreement with the schedule, with the specs, with what we're going to be doing. And how do you do that? Well, you have them involved early. And how does manufacturing know what they're agreeing to early on before it's designed? Well, they look at the written specifications. So this is all very important to tie all this together.
Okay, so with this broad range of experts here, I wanted to get a poke a little bit at what do you see in your different areas or areas of expertise as no longer a risk, and what are emerging risks? And we're going to start with Barbara.
Well, in plastic molding, oftentimes predicting the result was difficult in the past, and what I see now with a lot of the new modeling techniques that we're able to use, that there's not as much of a risk of, for example, part fill problems, because we can use mold flow analysis before we even construct the tool. And other cosmetic issues can be identified, potential blushing on the surface and things like that. That used to be it used to be that you found those things out after you built your tool, and then oops, now we've got to fix it or try to figure out how to not add that issue. But what is an emerging risk is that most of the tools are being constructed in other countries, and for cost reasons, because it is a pretty highly labor-intensive process. And then in our case, we're bringing those molds back here to be run, because injection molding is not a labor-intensive process, and that way we can be closer to our development base. But as a result, the construction and testing and sampling initially is taking place in a remote location, and I tend to have an engineer go and be there on site because of the problems that I had noted in the past, where either the tool will come in and it won't have the right fittings on it, because they'll swap out the fittings at the last minute because they've been sampling it in a mold house that has different equipment than we have, and then all of a sudden it's coming to us, and then we're sampling it, and we have to adapt it now. And so those are the new emerging risks in terms of being remote. And there's also the potential for them to not necessarily use the right material. We tend to ship the material, but if they sample it a lot and then they run out, they'll maybe pick something else. So those are the emerging risks that I've noticed in our plastic molding area. The other one is condensing timelines by skipping verification steps, which I think everybody in this panel has experienced that. And it ends up that you lose time. Sometimes especially in my case, because tools take a long time to make, they'll say start the build, and then oh, oops, we need to change the material. And well, material has different shrink rates, so you don't have the right tool. Oh, can we find a material that does this, that has the same shrink rate? So anyway, the verification steps are extremely important, all of them, and developing your specs before you start construction of your tooling, in my case, is very essential. Here's Mark.
So how many of you design folks use mock-ups early on in the development? Number of them. Rapid prototyping. You guys use RP? Yeah. So about 4 years ago, RP's been around, rapid prototyping's been around a long time, but one of our customers used it in a different way. It was still pretty expensive back then, now it isn't. But what he did is he said, all right, every week we're going to make a new prototype. I don't care where we are in the design. I don't care if it's half done. I just don't care. We're going to make one every single week. And we did. You know what? The design process went really fast. We found things that didn't fit early. We found components that had a spec sheet that looked like this and really looked like that. And, man, so prototype every week. And he sourced them all over the place, whoever could do the work and the material that was desired. So I think that's no longer a risk. You can knock out a lot of your design risks really quickly using rapid prototyping and other methods. These were GPS control systems for ag. Yeah, boy, smart guy. Now he taught me something, and now we do it all the time. Now it's like a habit. It's a good habit. We also take it even one. Oh, excuse me. Go ahead.
Did you get the turnaround when the prototype's down to a week, or was it a cycle from, let's say, you were building specs for 2 weeks prior, and just to get all the parts in, you get the spec down and put it together?
Well, so he built relationships. Said, so when I'm going to give you a bunch of business, Mr. Rapid Prototype House, and I want to be first. And he did, and they were willing to do it because they saw a long-term customer opportunity. So now you almost get it because that's the way they do it. But back then it wasn't. So very, very interesting. And just to study shape, sometimes you have an aesthetic interest on some device. Well, grow it 5 different ways. Let everybody else look at it full scale if you want. Nice. So I like that. The other one, my emerging risk, I call it global single sourcing. And one thing that's happening in the world now is you get very, very large factories that do one thing and do it so well that nobody else can compete. Their price drops really low and all the competitors get wiped off the face of the planet. And that's a problem because all it takes is an earthquake, a tsunami, a nuclear meltdown, and there goes that supplier. So I think that's a big problem that we're going to face in the future. I don't have all the answers for it, but I see it as a significant risk. You saw the hard drive play happen recently in Thailand. Good example.
So in the world of reliability, I started about 25 years ago, and when I started it was much of a throw-it-over-the-wall approach where you design it and then throw it over the wall and then the reliability folks do what they need to do. And there was a limit to how much you could actually improve or even obtain for product reliability. But the targets weren't that high, but they're getting much higher now. So we have methodologies, and it's really being adopted worldwide, designed for reliability. And it's both a terminology and it's a methodology, and it's really being applied and being applied well. So
Is that DFR?
Yeah, DFR. Yeah. So and I've done I've done lectures in Japan, Taiwan, China, India, and a lot of the engineers all over the world, they're getting it. And so it's not only here in the U.S., but it's really spreading pretty quickly. So I think it's not as much of a risk in terms of reliability if you do apply these principles. If you don't, then the risk is still there, and you're going to be limited to how reliable you can make the product. As far as emerging risks, there's actually a number of different emerging risks. I see emerging risks in new types of materials. We looked at RoHS, and now we're looking at REACH. Whenever we're going to new materials, there's always a risk. But that's not necessarily new today that wasn't here yesterday. It's just every day and every year we see new materials, and we just have to approach that and with our eyes open to say, all right, well, if we are going to this new type of material, new technology, what are the risks associated with it, and how can we mitigate those risks? Another one, Mark touched on it, was in globalization. I mean, we're offshoring a lot of things. Offshoring can certainly bring down the price, but there's also a potential for increasing the risk on the reliability, and we've all heard about potential quality issues and quality slips as we're going overseas, so we need to keep our eye on that very, very closely. I did mention that there are some standards being developed. IEC 60601 3rd edition, automotive industry has a standard 16949 that are really addressing, it's kind of like taking ISO 9000 to the next level. It's addressing these and saying not only do you have to have good documentation systems, but you have to actually prove to us what the risks are up front. So it's actually being built into the design for reliability process. So I call that partly a no longer a risk, but it's not well known yet. So it's still a risk that we need to mitigate. But using these kinds of standards can certainly help.
An area that is not really a risk anymore is wireless modules. It used to be if you wanted to do a wireless device, you needed an RF designer to design something, and RF is black magic. You design it and you try it out, and then you find how it really works and you change it. This is risky. Now you just buy a module off the shelf and you put data in one side, and very often the antenna is included in the module, or they give you instructions on exactly how to design it into the circuit board. So this has become much less risky. An emerging risk that's been continuously getting bigger is regulations. 30 years ago, there weren't very many regulations. You met UL and you were fine. Now you've got all kinds of regulations, and not just for medical devices. Everything is getting more and more regulations. And next year we're going to have more. It's not going to go down. If you don't meet these regulations, you can get away with it for a while. You can ship the product, the distributor can ship it out, and then what happens is somebody gets injured, or one of your competitors complains about your product and raises a flag, and then you may be shut down. That's really serious. You can't ship your product anymore. So not paying attention to the regulations can be really serious. And not doing it early can be a problem, because you may test for this at the very end of your development and discover you don't meet the regulation. You got to go back and redesign. So you have to think about it from the beginning. Yeah.
Great. Want to make sure we have enough time for audience questions. I've got a couple submitted questions, so I'll go through those, and then we'll try and leave about 20 to 25 minutes for audience questions.
That's online as well.
And that's online. Yeah, that's both audience as well as online. So
we are monitoring the questions online, so people can type them in.
Yeah. So the people online that are logged in, feel free to type in your question, and we'll try and get to it. Okay. So the first question is: share an example where technological risks were involved, and what did you do to mitigate those risks?
One of our customers is Abbott, and here in the Valley, and we have a very intelligent design engineer that we're working with, and what he wanted to do was do what we call floating core overmolding, which basically is an overmold with basically a hollow center, so that he could have features on the inside as well as on the outside. It was a big risk, had never been done before, and but he was convinced that it would work. And so what we did was we basically did a test mold for that before we went into production, so that we could be sure that it would work, and it did. He was right, and it's something that we can do now. But what's important, I think, is always try to reproduce the conditions that you're actually going to be manufacturing in, and that's the only real way to have that technological risk drop when you're trying to push the envelope like that.
So for me, we had a product we were doing earlier this year that it was a mechanism, and we were trying like crazy to not have electronics in it. Sorry, Walt. And because there was an expense and it had a power requirement and batteries and all this other overhead. It's like, can we do this purely mechanically? And we weren't able to do it completely. We had to put a timer in it. But the real technical risk on that one is kind of like the mousetrap game, if you guys have played it, right? One thing triggers another, which triggers another, which triggers another, and it was an interactive mechanical device that goes in the public domain. So all these little mechanical things happen with the trigger of one event. I can't tell you what it is. It's a secret, sorry. But the point is there was probably 5 different mechanical sequences that needed to occur throughout this device, reliably so. And friction was just driving us nuts, right? Anybody ever fought with friction? It's a variable. Temperature, humidity, and all other environmental conditions affect it. So we changed the friction as much as we could in the product to reduce it. But then it started to get really expensive. So, well, engineers know that friction times normal force equals the amount of force you have to deal with. So all right, we're going to play with the force. So we counterbalanced every mechanism throughout the design inherently without adding parts, right? Because we were doing plastic molding and sheet metal, so we could move masses to different places. So it turns out that we mitigated the risk by balancing each subcomponent throughout the mechanism. Now it works really well, and there's almost no wear. So it worked pretty well. I learned the hard way on that one, but worked out for the customer. Okay, next.
Yeah, Mark, I know what you mean by friction. That just burns me up. So a couple things that I've seen. You guys all have dealt with RoHS and probably now having to deal with REACH. You probably aren't completely aware of all the technological risks associated with that. You just think, well, you can't use certain materials anymore. Well, the solder material that we had been using up until about 5-6 years ago, depending on your industry, was something that was pretty tried and true. If you go back 50, 60 years ago, it was a bit of experiment, but over the last 50 years, we got to figure out and learn how to solder material using leaded solder. Once we switched to a lead-free solder material, there were a lot of technological challenges with that. The fact that you had to solder at higher temperatures, the fact that it was more brittle, just a whole bunch of different things that until you get into the material science of what the differences are, that really brought up a bunch of reliability risks. You know, things like, well, it's going to be more fragile if you drop it. Possibly it's going to, the added heat in manufacturing is going to cause a little bit more wear during the manufacturing process. So there's several things that we had to look at, and we mitigated them using a real targeted reliability test plan approach to say, well, where is your product going? What environment is going into? And is there a risk to your environment? And just an obvious example is if you're going into an environment where it could potentially get dropped, well, now you have your product's going to be more sensitive to this kind of a drop test, where if it's not going to be dropped, then perhaps it's not. So then we looked at, well, do you have to then reapply a drop test and possibly more of a drop test to failure to look at what your margins are? People just say, well, if I redrop it and everything works fine, I'm okay, but you don't know what your margins are, and you didn't know what your margins are before, so you're not really sure if you've increased your risk or not. And the other obvious example that we have seen is when you're looking at solid-state memory. How many people have ever seen one of these things before? So we're using these very commonly, but what they're now starting to do is putting solid-state memory in place of hard drives in terms of 24/7 access systems, like in banking systems and things where you're not doing a read-write on this thing maybe once a day. You're now doing it maybe once a second or a number of times a minute. So now there's potential wear out. We always thought that there was wear out going on with spinning hard drives, but nobody ever thought there was actually wear out with these. But in fact, there is, and we discovered some definite wear out mechanisms if you keep reading and writing to the same place on these. So there is some clever algorithms that have come up in order to get around that.
Well, Mark, I know you tried to eliminate electronics, but on that project you called me at least 3 times for help. But that points out that even if you're working on something that's in one field, having experts in another field may be very useful. A good example of a risk that we dealt with recently was on a device that monitors an AED, which is a defibrillator, the ones you find in airports. The challenge we had was we needed to detect it has a self-check and it reports on a screen what its state is, and we needed to read that and report it. And it seemed straightforward. You have a photo detector. It was, it was simple. We could just see if it was dark or light, and we provided illumination with an LED. And we even did the design enough so that it would work all the way from total darkness to full direct sunlight. And just to be sure, we did a prototype. We put it together, and it worked. And then we had the customer try it out. And they said, yeah, but your detector is getting in the way of the display. And they decided that that was not acceptable. And if we hadn't done that prototype, the changes, as a result of that, Mark changed the mechanical, we changed the electrical, the software was changed, everything was changed, and that's not something you want to do at the end of a project. So it was very important that we did it at the beginning.
All right, thank you. And the second question is, what about risks associated with transferring from design to manufacturing? Have anybody ever experienced those kind of risks? Okay. All right, Barbara, let's start with you.
We had a customer, Agilent, that was had been producing a part here in the United States, and we've been shipping to them successfully for 3 years. And then they decided they were going to move it to Malaysia, the manufacturing to Malaysia. And so we're still making the same part. We're doing everything exactly the same. And it's now being sent to Malaysia. And all of a sudden they're telling us that there's a modeled appearance on the outside of the part. And we're saying there's no way that it left here looking like that. There's no way. And so finally they ship the part back to the engineer, and the engineer comes to work with us in our conference room, and we're all looking at it going, there is no way that that shipped out like that. And then we as we're unwrapping it and we're looking at that and we're going, oh my God, it's the bubble wrap. It's imprinting itself on the outside of the part because it's sitting in a container in the heat and humidity, and the plastic of the bubble wrap is actually adhering to the outside of the part. And so one of the things that most of my medical customers don't remember, don't forget to do this, but some of the non-medical customers don't do transportation validation and packaging validation. And when you go to a new location, and you have to do your transportation and packaging validation to mitigate those risks.
That's a good one. Yeah, so in our case, there was a piece of test equipment that we developed that was going into a production environment in a contract manufacturing site, and it was a very special connector design that engaged with a circuit board for an automated test. And so we designed it, it worked fine, the customer got requirements, the customer loved it, and put it in the environment, and we get a call the next day and they say, hey, this doesn't work, it doesn't stick on where it should, it doesn't connect. So we're scratching our heads, like, well, what happened, in less than 24 hours? So we went in there, and it turns out that nobody had shown the operators actually how to use this properly in the first place. So it was purely communication, purely. Nothing had changed. It still worked just the same. Everything was fine. So I think in the future we'll just do a YouTube video or something that's more secure and say, here's how you do it, like this, and they'll get it. So that was so simple, but it cost us most of a day of work running around panicking that we'd done something wrong, and we hadn't. So, communication.
How many people have ever heard of the methodology Design for Six Sigma? Does that sound familiar? Yeah. So, so when you design and develop something, you're only going to get a certain number of prototypes to test. If somebody asks me how many samples do you want for testing, of course I'm going to want as many as I can, but realistically we may only get a few. So you're not going to be able to adequately look at all of the tolerances in just a few samples. So there's a lot of design analysis has to be done. So we've seen this happen quite often. When you get to manufacturing, all of a sudden you start hitting tolerance windows that you didn't think were there. So that's where Design for Six Sigma comes in. The other methodology we use is good manufacturing screening. We call it HASS, Highly Accelerated Stress Screening. We're actually over-screening the product. We're actually screening it up to the point and even beyond the point that the customer is going to use the product. We know what the margin is from the design, so we're not going to go to that point. But we want to make sure the product, every product, is going to work at least to what the customer is going to use it, and then some, to provide some margin, because you never know. You've got the random customers that may actually use the product outside of its specifications. Put your cell phone on the dashboard of your car. That's going to go beyond the specifications of the product. Drop your mobile phone from ear level. That's going to go beyond the specifications. So you need to make sure that not only you've designed to that, but each manufacturing sample can at least withstand up to the customer use environment, even a little bit beyond.
Well, I already mentioned one problem in transfer to manufacturing, and that was the part that became unavailable when the design was done. That's a common one. But a common problem in almost every project is what we call throwing the design over the wall to manufacturing. Has anybody ever run into that? There's a tendency for the engineers to focus on getting the design done to the point where they understand it. And manufacturing needs to have it to where somebody who's not very well trained can reproduce it every day. And there's a gap there. And there's a lack of understanding. And the way that you overcome that is to have more communication and to have manufacturing and engineering working together early and late. Engineering can't stop when they've thrown it over the wall. They have to be available for questions and fixing problems that come up later on. But there'll be fewer problems if manufacturing is involved during the design.
And design involved in the manufacturing. I actually saw one company in the Valley, the CEO, he was seeing this problem, and what he did was he told his design engineers, okay, your bonuses are now not only if your design is on time, but if the product gets out reliably. So they had to actually follow the product into manufacturing. The design engineers were flying around the world fixing the designs when they got into manufacturing, and then they realized, oh, well, maybe I should design it better so it's smoother into manufacturing.
Yeah, I remember in a company, this was a long time ago, I worked on a design, and then I was told by my boss, do not talk to these manufacturing people. You've got another project to work on. And they would come to me, and they needed help, and I couldn't help them. And it was frustrating, and they were frustrated. So, and that's not a good way to do it.
By the way, it's always management's fault.
Wait a minute, we have some management here. And it's also another reason why we're seeing a surge in onshoring, because of the issues between communication between design and manufacturing. And so if you're not a certain size company, there's more of a tendency to try to merge those back closer together. It's one of the reasons Tesla decided to not offshore their production.
Great. Okay, we got about 20 minutes left, so what I'd like to do is flip back and forth. Why don't we start with somebody in-house, and then we'll go online, and we'll just go back and forth until we run out of time. So does anybody have any questions for the audience? Yeah.
You mentioned ensuring that you meet regulations early on in design. Where do you go to find out what regulations are applicable for a product, especially if a product moves into different spaces in the environment?
Question is, where do you go to find out what regulations apply to a product? So anybody want to take that? Okay, Walt's going to take that.
There are people and companies who specialize in understanding and applying the regulations. For example, one area is in compliance. You've got to meet emissions, immunity, and various specifications like that. There are companies that do the testing, and they have people who stay current in the regulations. So at the very beginning of a project, one thing we do is we go to one of those experts and say, here's what we're planning on doing. What are going to be the issues and some of the things that will not be issues with this design? So that's how we find out about them. Now, you got to know who to go to and which issues. And with experience, we know that there are a certain range of specs, and unfortunately every year it gets more. So you've got to have some understanding, but then there are experts who are available.
Yeah, I agree with that. Yeah, it depending on your industry, what you're in, you're going to probably develop a network. With us, since we're in so many different industries, our networks have to be even bigger. We're working on an aerospace project right now, and they're developing hardware and software. And for the software, they have to comply to the DO 178 standard. If your software touches anything dealing with the controls of the airplane, you have to comply to that standard. And we don't know very much about it, but fortunately we have a partner that's an expert in that. So we bring him on the project, and he's a member of the team at that point.
Yeah, I agree with their approach. But the other thing I do, just to get a quick idea, is I look at all the competitive products as much as I can, and you'll see them. If they're pretty recent, they've had to go through this, so why reinvent the wheel?
The only comment I'd add to that is you can be overregulated too. So there was a project, the same project Walt was talking about earlier, where we thought the product was a Class 2 medical device, and we had a regulatory expert go through the process. They talked to the FDA. It turned out it was not a medical device, and that cut out probably $75,000 to $100,000 in the project budget. So it's important to know what you need to do, but also where's the line and what don't you have to do. Okay, and then are there any online questions?
Not right now. No.
Okay, well let's do another for the audience. Huh?
So my question is, it relates to medical devices. So ISO 13485 covers risk as it relates to both intended and unintended use. So can you cover the topic of unintended use and your thoughts on that?
The quick question is ISO 13485 use and unintended use. Do we have enough time here? Anybody want to take that? Okay, Barbara's going to.
Well, I'll start. One of the most common unintended uses is using it twice. And so one of the things that they're doing in plastic, at least, is that we're actually having that some of our customers are using materials that are not autoclavable. So there's that, and so that the whole device falls apart if they try to use it twice. It's just one example. It melts. It melts if you try to put it in the autoclave. So, those are the kinds of things that you can do to sometimes mitigate unintended uses.
Yeah, and medical is not the only industry that you have to look at. Whenever you're looking at product risks, you have to look at unintended use. A friend of mine was developing a product that was an altimeter that was going to be used for people skiing. So it was kind of a watch. It was a number of years ago. It was a watch that you can look at what your altitude was. And then they found out that the same folks in the winter that were skiing were doing rock climbing in the summer. So now all of a sudden these watches were being used for rock climbing, and they started breaking. Well, so they asked themselves, well, why would these people possibly want to use this for rock climbing? Well, why not? Right? I mean, they thought that was an unintended use, but the customer thought that was absolutely an intended use. So you have to think of how your customer may use and how they possibly even misuse the product, and make sure that you've thought through that design.
You want to? It looked like there was something online. Is there anything? No activity online. Okay. Anything? Any other audience? Okay. Well, I had one other one that just in case we ran out of questions, and that is, let me go back to the format here.
I know.
Yeah. Okay. This will be the last question. Share an example where supply chain risk was involved, and what did you do to mitigate it? And then we'll end with that.
You go first. I'd like you first.
So I think the best example is the one I already said, and that's where the helicopter manufacturer solved the problem. A key supply chain component that enabled a parabolic dish to work at a cost-effective performance. I also mentioned the biggest supply chain risk I've seen globally is single sourcing, and that's happening. I don't know how to stop it. So. Okay.
I think the biggest risk is tolerance stack-up that I see. We oftentimes are asked to do insert molding, and we don't have our hands on the inserts, and then we finally get a drawing and a spec for the insert, and it's got a plus or minus 10 thou, and they're asking us to hold plus or minus 2. And also we can't put it in the tool because it'll damage the tool if it's outside a certain spec. So I'd say that's one of the supply chain risks that I've seen a lot.
Earlier I talked about reliability and developing goals and good plans, and I think companies in general, they understand that fairly well when it comes to their own part of the design. But right now, in the world getting so flat, we're using other design firms around the world and bringing in parts from around the world. And what I've found one of the biggest risks is that we don't actually apply these same methodologies and standards to our vendors that we do to our own product. Let's say we're developing this laptop, and one of the key components of the laptop might be the display. Well, we're not designing the display. We're buying the display from maybe Taiwan or Japan or wherever it is, and we don't put the same requirements onto them and look at their design program, their design for reliability, their testing. So we're just taking it on face value. Oh, you say it's going to last 10,000 hours? Great. That fits right in with my reliability budget, and they don't question it, and they don't look at how they actually arrived at. And we've seen quite often some big surprises later on. We start getting into testing. Oh, I didn't realize that you didn't actually do any testing, that this was just a theoretical analysis, and you're kind of hoping for the best. And oh, by the way, you didn't even understand how we were planning on using this product. And so all of your numbers are not even applicable for our environment because it's a little bit apples and oranges. So we find that that's probably one of the biggest supply chain risks from reliability is not applying the same standards to our vendors as we are to ourselves.
A big risk in electronics is the transfer of products offshore. When you buy the parts in the U.S. and you buy them in China, they may be different parts, different manufacturers, different specs, different levels of quality, and the assembly is going to be done with different levels of quality and done in different methods. So one way that is reduced is you very often start manufacturing onshore and you transfer it offshore once everything is running smoothly, so that if there's a glitch, you have a way of continuing to manufacture. And many contract manufacturers do manufacturing onshore and offshore, so they can do that transfer for you.
Yeah, I also like how they do it consistently. They'll guarantee a match in both locations. Mature it here and move it there, for especially the high volume solutions.
Do they usually give you a choice? When you
Oh, yeah.
I've seen some that don't. They say, oh, by the way, your product is moving now. Yeah.
I've seen one we're working on now where the volume locally is extremely low. It's like 5 tables in a row, and that's their production, but their end game is millions of these things. So all they're doing is wringing out the process with this short production run capability, and in parallel, lining up all their ducts overseas.
The other comment I would add is, and I've seen this both on the electrical side and the mechanical side when I was in the manufacturing world, is risks where supply chain is really designed up front for prototype suppliers, and the company can't scale into volume, and then the contract manufacturer actually has to go and shift suppliers from a prototype supplier to a volume supplier, and that can be very, very painful, and it can take 6 to 9 months to make that transition. So, okay, well, I'll leave one last go for in-house or online, and if no, the pizza's there getting cold, so we should probably get to that. Any final question? Yeah.
Do you have any way to reduce risk also on shipment? Let's say the product is big, not small.
Mm-hmm.
Any strategies to reduce cost or the risk in the shipment, like fulfilling part of the
I mean, after finished build?
Yeah, we have everything is built and great, but now we incur very, very high shipment costs, or we have it's very difficult to fulfill the actual install the device. I'm not speaking about small machines.
Yeah. And so
Here, you want to repeat that?
Yeah.
Maybe restate the question.
Yeah. The question is, how do you minimize risk for shipping large products, probably expensive ones that weigh a lot and go a long ways for final shipment, not in build type supply chain management? Okay, so how to overcome it. So a story, a very large semiconductor equipment company in the Valley, there are many, I won't say who this is, but they have an entire department that just focuses on the standards and the methodologies of doing this. The problem with that model, in my opinion, is it's too slow when you're developing new things, right? Because they go through all the verifications that are and validations that are important, and they have to do that. But if you're doing early prototypes, you have an awkward middle space. So there's secondary processes that are somewhat overkill in the design. They cost more money, but they get you going in the beginning. And the other thing that we did in that one is we broke down the product to components that stacked in smaller formats and were more easy to protect. So we disassembled partially. And that was very helpful, because if we left it assembled, it would be a very awkward, never fit in an airplane kind of design. But when we broke it down, it almost stacked nicely. So configuration and process management are the best ways to deal with that.
Yeah, what I'm seeing is that there's a lot more last mile manufacturing. That's why as a molder, because we have the tooling, we'll end up shipping to the same customer to 3 different locations, one in Scotland, one in the U.S., and one in Malaysia or Shanghai or whatever, because there's more, I think, last mile manufacturing. There's what's called right sourcing, and so you'll put your final box assembly, you'll design it so that and also all of your custom adaptations that your customer might want this kind of model or that kind of thing on it, and you do all that closer to where your market is. And we have a partner here that does a lot of that here in the U.S., does last mile testing and assembly of the large boxes so that you don't have to ship them all over the place.
Yeah, ship the parts, not the finished goods. Okay?
Well, a couple more comments. If there's no other questions. So I want to thank the panel. So appreciate the time. And before we eat, if I can just request you fill out the evaluation card, and then turn that into the front table here, and then grab some pizza. And then there's about a half an hour to just meet and greet with the speakers offline here. And then I'm going to sign off for the people online. So thank you for the time, and we look forward to the next one.